Alright, long division with polynomials can be a little tricky, so I thought I'd make this little video so you can go back and refresh, just refresh your mind about it. Alright, so let's start with, what does simple division even look like? Hopefully we remember the algorithm that I got to figure out how many times does 8 go into 1. Well, it doesn't, so then I look at how many times does 8 go into 13. Goes in once, 1 times 8. I have to subtract. So 55, and then 6 times 8, so 48. Subtract. Leftover is 7. What do I do with that remainder then? Yes, I can add a decimal point and keep going, but if I wanted to stop, what would I do with the 7? I hope that we know to put it over the 8. So it's 16 and 7/8, which really means 16 plus 7 over 8. Right? I'm not multiplying those. I'm adding them together. Division with polynomials looks exactly the same. So let's first look at dividing these two. There's two different options if I have just one thing down here in the denominator. So let's look first at the long division like we did up in the first example. 12x cubed plus 3x squared minus 9x divided by 3x squared. Well, how many times does 3x squared go into 12x cubed? 4x. And I got that because I know 4 times 3 is 12. X times x squared is x cubed. So when I subtract these, I'm going to be left with 0. There's nothing left there. Then I bring down the next term, 3x squared. So how many times does 3x squared go into 3x squared? Once. 3x squared. Subtracting these. I've got 0 left. Bring down the negative 9x. Can I multiply 3x squared by something and get negative 9x? No. So this is where the remainder comes in handy. I'm going to add negative 9x over 3x squared. Can I then reduce this fraction? So my final answer will become 4x plus 1. If I'm adding a negative, that's just like subtracting. 9 divided by 3 is 3. X divided by x squared is x left in the denominator. So there's my final answer. So I can do that. Or option 2 says, well, 12x cubed plus 3x squared minus 9x divided by 3x squared is the same as 12x cubed divided by 3x squared plus 3x squared divided by 3x squared minus 9x divided by 3x squared. Can I simplify each of these fractions? Well, yeah. 12x cubed divided by 3x squared is 4x. 3x squared divided by 3x squared is 1. This is still 3 over x. So you'll get the same answer. This only works when you only have one thing going on down here. If I've got a 3x squared plus something else, doesn't work. So let's look at one of those problems that would be a 3x squared plus something else. So I can write this problem in a couple different ways. First, I can write it with just division right here, or I can make it a fraction. They mean the same. If I'm dividing, I'm going to set up my long division. Okay, so this is a little tricky. What you're looking for is what the first term, so x, how many times does x go into 3x squared? So it's got to have a 3, and it has to have an x. Then I need to multiply 3x by this whole thing. by the whole divisor, right? We know this is the divisor. And this inside is the dividend. Hopefully we've seen those words before. So I need to multiply, and then up top is the quotient. I need to multiply the quotient by the entire divisor. So 3x times x is 3x squared. 3x times negative 4 is negative 12x. Now I have to subtract this. So I need to subtract this whole thing. So what's 3x squared minus 3x squared? Well, that's 0. Those are gone. What's a negative 5x minus a negative 12x? Well, that's really negative 5x. Change both these to plus 12x. So that's 7x. Bring down the 2. So now I'm thinking, what multiplies by x to get 7x? Well, that's 7. So I'm going to add 7. 7. Now I have to multiply 7 times x and 7 times negative 4. So that would be 7x minus 28. I'm going to subtract again. I'm subtracting this whole thing. So if it's easier for you, go ahead and distribute this negative. So make this a plus, make that a negative 7x, make this a plus 28. That's how I like to do it. I like to add much more than I like to subtract. So now what do I get when I add these things together? 7x plus a negative 7x, gone. 2 plus 28 is 30. So 30 is my remainder. So I have to add 30 over x minus 4. So that's my final answer. This equals 3x plus 7 plus 30 over x minus 4. That's it. Let's try some more. Okay. 3x squared plus 8x minus 4 divided by x plus 2. So again, I'm looking at the first term and the first term. So what do I have to multiply x by to get 3x squared? That's 3x. Then I multiply 3x by both parts of the divisor. 3x squared plus 6x. Now I've got to subtract these things. So this is gone. And then I have 8x minus 6x. So that's 2x. Bring down the 4. So now I'm looking at x and 2x. So what do I multiply by x to get 2x? That would be plus 2. So then I take 2 times x, 2 times 2, so that's 2x plus 4. Remember, you have to subtract these. So 2x minus 2x, those are gone. Negative 4 minus 4 would be negative 8. So my remainder is negative 8 over x plus 2. Easy, right? I'm sure. Okay, let's try this one. X squared plus 9x plus 20 divided by x plus 4. So I'm looking for, what's this x in the first term here? X squared. So I need to multiply x by x to get x squared. Multiply, multiply. So now I have x squared plus 4x. I need to subtract. I'm putting the parentheses there because I need to subtract both terms, right? I hope we've caught on to that. X squared's gone. 9x minus 4x is a 5x. Bring down the 20. So now I'm looking at what does the x and the 5x. So x times a positive 5. Subtract. 5x gone, 20 gone, so I have no remainder this time. So these divide evenly. This means x plus 4 and x plus 5 are factors of x squared plus 9x plus 20. If I were to multiply x plus 4 times x plus 5, I would get x squared plus 9x plus 20. Oops. Plus 20. They're factors. Okay, what about a problem where there's a part missing? So first, what part is missing from this? Up here, what do you see that's missing? There's no x squared. So I've got 4x cubed, there's no x squared, minus 7x minus 5. I'm going to leave a little hole. So I'm looking at 4x cubed and 2x. So that means I have to multiply by 2x squared. Multiply, multiply. 4x cubed plus 2x squared. I left a hole, which really means 0x squared, so that I could line these up. Now when I subtract, I have something to subtract from. 4x cubes are gone. 0x squared minus 2x squared becomes negative 2x squared. Bring down the 7x. So now I'm looking at 2x and negative 2x squared. So I need to multiply by a negative x. So that would be negative 2x squared minus x. I'm going to subtract this whole thing. So that makes plus plus. These are gone. Negative 7x plus x is negative 6x. Bring down the negative 5. Now I'm looking here, which means it's going to be a negative 3. Let's multiply negative 3 by each of these. Negative 6x minus 3. Subtract. These are gone. Negative 5 minus negative 3 is going to be negative 2. So that'll be my remainder. So this equals 2x squared minus x minus 3 minus 2 over 2x plus 1. Okay, let's try another one. X cubed minus 1 divided by x minus 1. So this one there's a lot missing. There's no x squareds, there's no x's, then there's the minus 1. So x times x squared gives me x cubed. Multiply x cubed minus x squared. To subtract these. Gone. So I have x squared plus 0x. So I have to multiply by x to get x squared. Minus 1x. Subtract these. So now I have 1x minus 1, which is just a positive 1. Because when I multiply 1 times x, I get x. 1 times negative 1, I get negative 1. When I subtract these two things, I have a remainder of 0. So that's it. I'm not going to have time to do this last one, but it's the same process, just with 3 terms now in the divisor. Alright, best of luck.